All right, so now we continue our discussion, and this time we will be covering about real numbers and the number line. And so our goal will be to classify, graph, and compare real numbers. So of course, some words to remember first: a set. So a well-defined collection of objects. So for example, the set of alphabet. Okay, so those are the letters of the alphabet, all 26 of them. All right. Next, element of the set. So each object that is in a set. So every letter that you mentioned that is a part of the alphabet is what we call as an element of the set. And when we say subset, it consists of elements from the given set. So it's a smaller set within the bigger set. So if our set is the letters of the alphabet, a subset that we can say would be the set of vowel letters. Okay? So that's what a subset is. Now, when it comes to the numbers, there are different sets and subsets of numbers, and they could be classified based on their characteristics. Okay? So the most basic set of numbers would be the natural numbers, and these are the set of counting numbers. Now remember, counting numbers. What number do you start with when you start to count? It's 1. So it's 1, 2, 3, until I don't know what, all right? Those are what we call as the natural numbers. The moment that you add 0 to the set, that is now what we call as the whole numbers. So you see here, the only difference between the natural numbers and the whole numbers is that number 0, all right? Integers, on the other hand, is the whole numbers plus the negatives as well. So as you can see, you have your negative values and the positive values. So that's when you have your integers. The next bigger set will be what we call as the rational numbers. So if you take a look at the keyword here, which is ratio, these are numbers that can be expressed as a ratio, like A over B, in such a way that A and B are both integers, and it is important that B is not 0, okay? We do not allow 0 in the denominator, or else it will be undefined, all right? And so if we have rational numbers, we have the opposites, which are the irrational numbers. Irrational numbers, these are numbers that you can never represent as quotient of 2 integers. So to visualize this number system, this real number system, we actually, oh, sorry, I forgot. We still have the real numbers. I thought I was done with irrational, my bad. So real numbers, if you combine rational and irrational numbers, that whole group is what we call as the real numbers, and pretty much that, okay? So if we're going to visualize it, we have this diagram. So again, the smallest set of numbers will be your natural numbers, okay? Square root of 25, what's the value of square root of 25? It's 5. You use 5 to count. 7, 4 over 2, what's the value of 4 over 2? It's 2. It's a counting number, so it's a natural number. And again, whole numbers, you just add 0 to this group. If you add the negatives, that's when you have your integers. Now 10 over 5 is 2. So this number is actually negative 2. Square root of 16 is 4. You put the negative sign in front of it, so this is still an integer, okay? And then the next one, the next group is the rational number. So this now includes our fractions, okay? A over B, negative 2/3, all right? Square root of 25, that's a specific value. Decimals are also included in rational numbers. Now, it is important to note here, with the rational numbers, radicals that can be expressed, that can be simplified, okay? They are included as rational numbers that can be simplified, okay? Just like square root of 25 equals to 5. That's included as a rational number. Repeating decimals are okay, so definitely terminating decimals are also included here. So let's say 0.25. The decimal stopped. So that's a rational number. And decimals are repeating. Repeating decimals, just like what we have here. How do you know it's repeating? Because of that bar on top. So they are included in the set of rational numbers. Now there are radicals, and there are radicals that are considered as irrational numbers. What's the difference? Okay? Here, if the radical can be simplified, it is a rational number. You can get a specific value. On the other case, for example, the square root of 10. You cannot get the exact value of square root of 10. This is going to be a non-terminating and non-repeating. So these will give you non-terminating, meaning they will not stop, and non-repeating decimals, repeating decimals. Okay, and I believe that example is this one here at the bottom. We also have what we call as transcendentals. That's the term that we use, transcendentals. And these are your math symbols like pi. Pi is 3.14, 16, and so on. It's never going to end, okay? Another transcendental that you will see in higher algebra will be the E symbol. It also has a numeric value that does not end. So those are the irrational numbers. So all of these numbers are what we call as real numbers, okay? So let's go to our examples here. So what I need you to do here is to identify to which subset of real numbers they belong to. So 15. So we always start with the smallest group. Our smallest group is counting numbers or natural numbers. Is 15 natural? Yes, it is. Is it a whole number? Yes, it is. Is it an integer? Definitely. Is it a rational number? Can you write 15 as a ratio of two different numbers? Well, because 15, I think I can write it as 30 over 2. Okay, 30 over 2 is a ratio, so definitely it is a rational number, and definitely it's going to be a real number as well. Okay? Let's have the next example. Negative 1.4583. 1.4583. Is it a natural number? Nope. You do not count with a negative. Okay? Is it a whole number? Again, whole number is 0 and the counting number. So this is not a whole number. Is it an integer? Right now, no, it is not. It is not an integer. You have to remember, integers are positive or negative numbers. Okay? Is this a rational number? Yes. Okay? Negative 1.4583 is only, it belongs to the subset rational. Again, just because it has a negative sign in front doesn't mean it is an integer. Okay? So that's the importance of you being able to distinguish the different subsets. Okay? So this number is only rational. And definitely real, of course. Alright? Now next, the square root of 57. So when you have your radicals, only one question to ask. Can you get the exact value of it? We know that 57 is not a perfect square. So the fact that it is not, you cannot simplify this, you know that you will have a value that will never end. And this means that the square root of 57 is irrational. But even if it is irrational, it is still a real number. Okay? So you can try this next numbers in here on your own. You can classify what kind of numbers or what subsets they belong to. So for these two examples, 36 is a natural, whole, integer, rational, real number, all of it. And the square root of 121 over 16, because it can be simplified as 11 over 4, then it could be classified as rational and real.